Friends, I'm Vijay Singh, and I come to you with the fourth episode highlighting our rich heritage of rural mathematical riddles. Uh, at the outset, I would like to thank Ranjana Patak and Akshat Mishra. As you know, and as I've already told you in the previous slide, previous episodes, India has a vast repertoire of and a vast tradition and a vibrant tradition of oral culture. We have stories of animals and sagas and ballads, but we also have a large number of riddles, out of which a small subset are mathematical riddles. Okay. This is a map of India. This is Kusumpura. I'm sorry, I got this is Kusumpura, and this is where Aryabhat lived. This is medieval India. Kusumpura is modern day Patna. This is where Aryabhat lived 1500 years ago, and most of the riddles are from the Bhojpur region, and basically they are from over here. But let me begin with a riddle from rural Tamil Nadu, so that you don't get the impression that all the riddles are from the Bhojpur region. Okay, and Tamil Nadu is right here, as you know. Okay, first this riddle is Parakam Anal Parantu Pogatu, which means I fly, but I do not fly away. There is one point I would like to clarify. The riddles are necessarily in the vernacular language. They have the right cadence and rhythm in the vernacular language. So I shall be reciting the vernacular, but I assure you that I shall be translating it into English and explaining it into English. So what is this thing which flies but does not fly away? The answer is right in the picture. It is the flag, the Indian tricolor, for example. It flies but doesn't fly away like a bird. So let me begin with the riddles, and this is a brain teaser, a simple one. Okay, and this riddle goes like this: the guru, you can see the guru sitting here, and his spouse, each weigh 9 mons each. Okay, that is each weigh about 360 kilograms. The two disciples of the guru together weigh 9 mons, or 360 kilograms. The boat can handle 9 mons, or 360 kilograms. How will they all cross the Ganga? So while you're thinking about it, let me recite the vernacular Bhojpuri one. Nauman ke guru, nauman ke guruain, nauman ke dunnu chela, nauman bhar naiya sahela, bari bari kaise par karela. This riddle is to be found all across India, I can tell you, in various forms. There is a riddle similar one about a person, a goat, grass, and tiger, and only two can sit on the board, and how will they cross it? So figure this out for yourself by trial and error, because most of these riddles have to be solved not by any deep knowledge of mathematics or game theory, but by the Baithaki approach. Baithana means by trial and error, by guesswork, by clawing towards the solution with the most elementary mathematics. This particular episode is dedicated to very large numbers. And kids and elders and even folk people, simple folks, were comfortable with very large numbers. To give you an idea, here is one, which is physics, transformation, as well as very large numbers. A pious python is crawling towards the holy Ganga for a holy dip. His space is 1 angul. That is, an angul is anywhere between 3 to 6 centimeters. Let us take it to be 5 centimeters. His space is 1 angul in 9 days. Okay, look at the units. How long will it take this determined python to reach the Mother Ganga, which is 80 kos away? I have not written that part. I'm very sorry. 80 kos away means which is 256 kilometers away. 1 course is 2 miles, 1 mile is 1.6 kilometers. Sorry, I didn't write the distance. So, एक अजगर चला नहाई 9 दिन में अंगुल भर जाई, 80 कोस गंगा का तीर कैसे कब पहुंचेगा अजगर वीर? Okay. So you have to do the transformation from centimeters to meters, from kilometers to meters. Do this velocity problem, okay, velocity distance problem, and the answer turns out to be, I've put it on the website also. It's 10 to the power 5 years, unless I'm wrong, which is quite possible. Okay, it's a huge number that you get. and you have to scratch your head that it'll take 1 lakh years, uncle, the grandfather, and he'll say, yes, it takes 1.25 lakh years. Here's another problem, a really tough one whose solution I will not give, but it also involves a knowledge of how exponentials grow. A mendicant approaches the last driver of a 16-cart caravan, and each is carrying 16 mounds of rice. Here you see the conversion. I would like you to keep this conversion with you for somewhere, because it's a very interesting conversion of medieval, and all over, I would also say in British India we had it. 1 mound is 40 sales, etc. 1 sale is 16 chatak, 16 chataks. And finally you come to a chawal, and the smallest one is a khaskhas. Okay, a tola is about 10 grams. That's why I say give me 1 tola of gold, and a chawal is 0.01015 grams. Okay, so these are the conversions you have to work with. What he does is the cart driver in the back refuses. He says and then shoos them off by saying that get something from the 15th, and then he, the 16th, will double the amount. The mendicant goes from cart to cart, and each driver brushes him off with the same lame sop until the first driver, taking pity on him, doles out some rice to him. Happily, the mendicant goes from driver to driver, backwards, diligently collecting double the amount. And I remind you, this mendicant is a shrewd guy. The last driver has to part with the entire cartload of 16 mounds. Entire. So how much did the first driver give the mendicant? Okay. Use the conversion provided. I will not give you the answer. Please write this answer on the comment box of YouTube. Okay, I will go to the last problem here, and it is an interesting problem coming from Rajasthan area, and it is one which honors Brahmagupta, who also was in, I believe, Ujjain, close to Rajasthan. Okay, a dying person leaves 19 camels to his 3 sons in this manner. The eldest gets half, the middle a quarter, and the youngest 1/5. After his death, a dispute arose, since there was no way you could do this division without cutting up the camels. Well, half of 19 is 9.5. You cannot have half a camel. Then his wife's sister came riding from afar to mourn and pay her condolences to her brother, who was also very clever, and so was the sister. She was wise too, besides being clever. She sat and patiently solved the problem to the satisfaction of the 3 quarreling sons. How did she do it? I mean, you can scratch your head and you can scratch your head, and I don't think you will get the answer unless I tell you. Okay, so I have to tell you the answer. What she does is she begins with the positive assumption that this dispute can be solved. She tries 18 by saying that I'll take one camel as a legacy, but it doesn't work. Then she adds her own camel and makes it 20, and this works because half of 20 is 10, 1/4 of 20 is 5, and 1/5 of 20 is 4. So that adds up to 19, and she takes her own camel back. This is called the method of virtual method. And the reason I am reminded of Brahmagupta is because he invented the Bhavana method, and it was the first for world mathematics. You assume that a space of solution exists, even if you don't know the solution. Okay, and this is a new way of thinking that Brahmagupta introduced into mathematics. Okay, so anyway, these were riddles that our elders and grandparents in our villages, both my mother's village and my own village, told me on wintry nights under the starry sky. So I dedicate it to them as a legacy that I have gotten from them, and it's a treasure that I will share with all my grandchildren. Please leave your comments on the Physics Sutra official website, and you can also see a paper and other interesting papers on my ResearchGate profile. This is the 4th episode. Perhaps there will be more if I get encouragement from you. Thank you.